Right, so we're going to look at 3D shapes. We're looking at cylinders, cones, spheres, and hemispheres. Okay, so if we look at the formula for the volume of a cylinder, it's in your log tables on page 10. Okay, it's pi r squared h. So r is the radius and height, it's the perpendicular height of a cylinder. Your units for volume are units cubed. Okay, so once you know the radius and you know the height, sub it in and get your volume. Again, if they tell you that you're to use pi as 3.14, replace pi with 3.14. If they tell you to use pi as 22/7, then use 22/7. And if they tell you nothing about pi, just use pi on your calculator. Depending on what way they want you to give your final answer, they might say give it in terms pi. So make sure you leave a pi symbol in your answer. If they want it to decimal places, then you'll be pressing SD on the calculator. If we look at the total surface area of a cylinder, so if you open it out as the net of its shape, you've got a circular top and bottom, okay, the base and the lid, like a tin of beans. Then the curved surface area, which is this region here, all that's a curved surface. It's like in a tin of beans. If you take off the label on a tin of beans, the label would be rectangular. So if you're to get the curved surface area of a cylinder, this is just the curved surface area part. So it's length by width for a rectangle. The width is the same as the height of the cylinder. To get the length of that label, that rectangular label, the label would wrap around the top of it. The top of it is a circle. So that length would be the same as the circumference of a circle. So if you get the circumference of the circle, which is 2 pi r, that will give you the length of that label. So therefore, the area formula for the curved surface area of the cylinder, which is technically a rectangle, length by width. So the length is 2 pi r and the width is h. So that's where this is coming from, and that's in your log tables on page 10. 2 pi r h is the curved surface area of a cylinder, which is a rectangular label on a tin of beans. Then if you want to get the total surface area, TSA, total surface area, well, once you've found the curved surface area, all you have to do is add on two circles, the top and the bottom, which are the same as each other. So get the area of one circle, which is pi r squared, double it, that's 2 pi r squared. So there's the formula then for total surface area. It's the curved surface area plus 2 times the area of a circle. So 2 pi r h plus 2 pi r squared. All right, that formula is not in your log tables. This one is, okay, the curved surface area. You have to know yourself that if they then ask you for the total surface area of that tin of beans, then you have to add on the top and the bottom. So you're adding on 2 circles. All they did here was they just factored out 2 pi r. You don't need to bother doing that. Okay, just leave it as that formula there. 2 pi r h, curved surface area, plus the area of 2 circles. And that will give you the total surface area of a cylinder. So always try and draw out the net of the shape to get a feel for what it is you're looking at. Okay, next we're going to look at a cone. So it's called a right circular cone. The top would be directly above the centre of the base. That's the only reason it's called a right circular cone. All right. We don't see any other types of cones, really, to be honest. Okay, so perpendicular height is here and the radius is here. Formula, which is in your log tables on page 10. It's a third, pi r squared h. That's your formula for the volume of a cone. Once you know h and you know r, just sub it in. And your units will be units cubed. Always make sure as well that all of your dimensions are in the same units of measurement. So if the height was in meters and the radius was in centimeters, you'd need to convert to make sure you're all in the one unit of measurement as well. Okay, now we're looking at the surface area of a cone. So remember, a cone, it's made up of a circular bottom and a curved circular side, if you want. Well, I won't really call it a side, but it goes all around the cone. If you think of a cornetto, and a cornetto has a wrapper going all the way around it, that would be the curved surface area. The cornetto also has a lid on top, which is a circular lid. Okay, so in your log tables, if I just want to get the curved surface area of a cone, which is this region here, that's the curved surface area, okay? The wrapper around the outside of a cornetto. Curved surface area formula is pi or L. So R is the radius, L represents the slant height. So here's L. If you don't know L from the diagram, you can easily find L by using Pythagoras' theorem. Because Pythagoras' theorem is the hypotenuse, which is L. L squared is equal to the height squared plus the radius squared. So you can use Pythagoras to figure out what L is, and L is the slant height of a cone. So you need to get L in order to get the curved surface area of that cone. And then if the question says find the total surface area of the cone, that means you're going to add on a circular end onto the curved surface area. So it would now read as this. So total surface area of a cone is the curved surface area, which is pi r L, plus the area of one circle. You don't need to do this. They just factored out pi r, and then we're left with L plus r in the bracket. You don't need that, okay? So this is what you would work with. The curved surface area, which is pi r L plus pi r squared. Again, this is not given in the log tables, but this one is. So once you know what curved surface area is, you should know that all you have to do is add on a circle onto it, and that will give you the total surface area of a cone. If I was to draw the net of that cone, so let's say here is the circular end, okay, down here, circular end, and then if I was to open out the net of the curved surface area, it would end up looking like a sector of a circle. All right, so it looks something like that. So that sector, if I fold it back up, it will fold into that conical shape. Okay, there's your curved surface area. And then you have your circular end, which is here. Okay, so that's what the net of that shape would look like. Also, the slant height here of the cone would be equivalent to the radius of the sector. The circumference of the circular end would be the exact same as the length of this arc. Because if it folds back up, that arc would wrap around the circle. So that's why the two of those would be equivalent to each other. So that's just something to bear in mind as well when you're drawing the net of the shape of a cone. Next, we're looking at spheres, the volume of a sphere, a football. Log tables, page 10. 4/3 pi r cubed is the formula for the volume of a sphere. The surface area of a sphere is... There is only the curved surface area of a sphere. So technically here, the curved surface area is the same as the total surface area. The formula is 4 pi r squared. Log tables, page 10. If we're looking at a hemisphere is half of a sphere. So basically, if you were to get the volume of a hemisphere, this formula is not in the log tables. But this one is. So if you know that the formula for a full sphere would be 4/3 of pi r cubed, you could use that and then half it. A half of 4/3 is where the 2/3 is coming out of. Okay, so a half of 4/3 pi r cubed. A half of 4/3, that's where the 2/3 is coming from. So it'll be 2/3 pi r cubed for the volume of a hemisphere. If we want to get the surface area of a hemisphere, so the surface area of a hemisphere is made up of the curved surface area, which is here. Okay, that's the curved surface part. So if you think about it, if it was a bowl, that's the outside of the bowl, that's the curved surface area. If the bowl happened to have a lid, which they usually don't, but if it did, well then you'd have to get a circular top plus the curved surface area, and that will give you the total surface area, okay? So in your log tables, these formula are not there, but you do know the formula for spheres. So the curved surface area on a sphere, or the total surface area for a sphere, is 4 pi r squared. Okay, so if it's 4 pi r squared and you want to get half of a sphere, just half of that. So it'll be 2 pi r squared for a hemisphere. So that's where this is coming from. Half of a full sphere would be 2 pi r squared for the surface area. Okay, and that's just for the curved part. To get the total surface area, you will add on a circular top onto that answer. So it'll be 2 pi r squared is the curved surface area of the hemisphere, plus a circular top, which is pi r squared. And if you add the two together, they are like terms. So you're getting 3 pi r squared. So neither of those two formulae are in the log tables. But you know the formulae for a sphere. So you're having those formulae. And just bear in mind whether they want curved surface area or if they wanted the total surface area. You need to add on a circle. Okay, if we look at this example. A cylinder of wax, so cylinder is a key word there. It has a volume of 426 and 2/3 pi centimeters cubed. So we're in centimeters. It's melted down into 2 other candles. One of those candles is in the shape of a sphere, which has a radius of 4 centimeters. You should always draw what they're talking about in the question. So there's my cylinder, there's my sphere, 4 centimeters of a radius. The other candle is in the shape of a cone with a radius that is half of its height. Okay, so I'm going to draw that. So there's my cone. It said the radius would be half of the height. So if I call the height h, well then the radius is half of that. So the radius must be a half of h, or you can call it h over 2 if you want. Okay, you can obviously manipulate this equation then. Like I've written R in terms of H, but you could also write H in terms of R if you want as well, just by bringing up the 2 and multiplying it instead. And then you'd have H equals 2R. So you can do that as well. So H would equal 2 times R. Okay, back to the question. So I've got this cylinder of wax, and I should say as well, they gave me the volume. The volume of this cylindrical candle is 426 and 2/3 pi centimeters cubed. Right, that's the volume of that cylinder. That's going to be melted down, and it's going to be melted down into the shape of those 2 candles, the sphere and the cone. Assuming no wax is wasted, so that means the entire amount of wax in that cylinder is going to be used. They're not wasting any of it. Calculate the dimensions, so there's your keyword. Find the dimensions of the cone. Right, when they say the dimensions of a cone, what dimensions does a cone have? It has a perpendicular height and it has a radius. So that's what it means. It says find the height and find the radius. Well, if I can find the height, I can automatically find the radius by subbing into these equations that I created. Okay, so the full volume of this candle is melted down into those 2. So that means the 2 of those, their volumes, right, that shape plus that shape, their volumes added together should equal 426 and 2/3 pi. So that's what I'm going to do. So I'm creating my equation. The volume of the sphere plus the volume of the cone should equal the volume of the cylinder. Okay, I'm subbing into it. The formula for the volume of a sphere is 4/3 pi r cubed. A cone is 1/3 pi r squared h, and that equals the volume of the cylinder. Tidying it up, okay? Well, actually, what I did in the next line is I divided across by pi, because pi is common to all 3 terms. So I'm going to divide across by pi. Okay, so now you're left with this equation here. Now remember, you can only ever solve an equation if you have one unknown. But we have 2 unknowns. We've got r and we have h. So this comes back down to the information that we had down here. R can be written as h over 2, or you can also say h could be written as 2 times r. So if this is just that little bit easier. If I use h equaling 2r, I am going to replace, everywhere I have a h in this equation, okay, replace it with 2r instead. So that's what I'm doing in the next line. So it's going to be 4/3. The radius of the sphere was 4, so I sub in 4 to be cubed, plus 1/3 r squared multiplied by h is 2r. And that should all equal that volume. Tidying it all up, multiply this out, you're getting 85 and 1/3 plus r squared multiplied by that r there will give you the r cubed. And 1/3 multiplied by 2 is 2/3, and it's all equal to that. Bring over the 85 and 1/3 and subtract it, and you'll get 341 and 1/3. Get r cubed on its own by dividing across by 2/3 next. And then you're left with r cubed equals 512. Get the cube root of both sides, and you'll get r is equal to 8. The radius is measured in centimetres, so that's 8 centimetres for that radius. So I've now found the radius of the cone, but they also said find the height, because they said find the dimensions. So if r is now equal to 8, sub in 8, and you'll get height is equal to 2 times 8, which is 16. Okay, so we're now getting 16 centimetres for the height. So therefore the dimensions of the cone, radius is 8, and the height of the cone was 16 centimetres. So always create your equations for yourself, put it into English first, and then use your maths to figure it out. Okay, the next example. An experiment to measure the volume of a metal spherical ball is conducted. Keyword, spherical. The ball is dropped into a cylinder of water. So there's already water in that cylindrical container. When the ball is dropped in, what do you think will happen to the water height? It's obviously going to rise up, okay? The cylinder has a radius of 5 centimetres and it has a height of 9 centimetres, and it's also half full of water. I'm going to fill that into my diagram. Okay, when they said it's half full of water, that means if the full height of the container is 9 centimetres, well, if it's half full, the water obviously rises up to half the level, so the height of the water would be 4.5 centimetres. Half of 9, 4.5. Right, when the ball is dropped into that cylinder, the water level will rise by 4 centimetres. So I'm going to draw in a new water level. Okay, so it looked like that. So the water level rose up by 4 centimetres. This little shape here that I've shaded in red, because that is the rise in height of water, that's a new little cylinder. Okay, that little red shape. Because now remember, this ball, it's now submerged under the water. So the ball is actually down here now. All right, it's under the water and the water level rose up. the water level would have risen up by the same amount of water that is equivalent to the volume of the ball that was dropped in. They have to be the same as each other. If you drop a golf ball into a glass of water, the volume or the capacity of that ball would have to be the same as the amount of water that it rose up by in the glass. Okay? So the question says, find the radius of the ball and give your answer to one decimal place. Because they never told me what the radius was, so I have to find that. So we're looking for r in this question. Okay? So the radius of the sphere. Okay, so here's my new diagram. The volume of the ball should be equivalent to the volume of the new amount of water. So this red region here. So if I get the volume of the ball, I just don't know the radius of that ball. So I'll leave r as r. And then if I get the volume of that new little cylinder, and I know the dimensions of that new little cylinder. The dimensions were, the radius of the cylinder was 5. So from here to there is 5 centimeters. And I also know that this height from here to here is 4, because it rose in height by 4 centimeters. So I can now go and get the volume of that new little cylinder, get the volume of the sphere, and let them both equal each other, and I'll solve for r. Okay? So over here, the volume of the new little cylinder that's been created. It's a cylinder, so pi r squared h. Leave pi as pi. The radius was 5 to be squared, and the height was 4. That works out to be 100 pi centimeters cubed, and I've left it in terms of pi. You can write it in decimals, but just don't round up. Then I'm going to go and get the volume of the sphere. The formula for the volume of a sphere is 4/3 pi r cubed. The volume of the sphere should be equivalent to the volume of the new little cylinder that was created. So I'm letting them equal each other. Divide across by pi because it's common to both sides. You're then left with 4/3 r cubed is equal to 100. Divide across by 4/3 on both sides next to get r cubed on its own. Therefore r cubed will now equal 100 divided by 4/3 is 75. Then to undo a power of 3, get the cube root of both sides. R is now equal to the cube root of 75 works out to be this decimal. And the question did say to round it to one decimal place, so the radius of the sphere is approximately 4.2 centimeters. Okay, so my advice for any of these kind of worded questions, draw your diagram to try and visualize what it is that's happening in the question. Fill in all your information into the diagram that you can before you start answering the question.